Hi everyone, are you able to hear me clearly and see my screen clearly? Yes? All right. Okay, so, all right. A question from Sunny. I have added a class for sorting in descending order, but I'm still stuck with the same problem. Okay, so Sunny, why don't we do this? Let's have one is that you drop me an email at support@nobigdata, or let's schedule a one-on-one session so that we can get into that. Sure, sure. Okay, that'll be better. All right. So just when you are scheduling the one-on-one session, please send your 3 suggested time, and I'll pick any one of those, and that should be good. Okay. Yes. All right. Okay. So today we are going to discuss something called input splits. Okay. Today we are going to discuss something called input splits or input formats. All right. So what you see here is an interesting diagram. Okay. It's a very interesting diagram. Imagine that you have a big file which has 11 lines. You see these 11 lines? Right. So in these 11 lines, the lower side here, the bottom side is, this is the block boundary from here till here. This is the block boundary. And from here till here, it's another block and then another block. So there are 3 blocks, right? And the first block's boundary is actually at a very wrong place, as in the 5th line is, most of the 5th line is in the first block, and remaining 5th line is in the second block, right? So what exactly are we talking about? We are talking about HDFS blocks. In HDFS, we cut the line, cut the data based on number of bytes, which means that the boundary could be anywhere, right? Here in this diagram, the boundary is in the line number 5, which means like 80% of the line number 5 is inside this block, and remaining is in this block. Block is nothing but a file created by data block on the data nodes. File created in the data nodes. Okay. Now here is another boundary. This boundary is in the 9th block, such that around 85% of the block or 85% of the line is in the first block, and 85 remaining 15% is in the 3rd block. Okay. Now, when we are processing our word count, remember the way we are processing the word count? We're processing the word count such that we want the whole line per mapper, right? The whole line is our record that we want to process, correct? So we would like to process the whole line instead of partial whole line, right? And imagine there is a mapper instance here. Map function executed on first line, second line, and third line, and fourth line. On the fifth line, since some of the fifth line is on another node, this data will be copied to the first node. Why? Because mapper is executed nearer to the data. Okay? It is executed nearer to the data. Similarly, some part of the ninth block will be copied to the second node, second data node where the mapper will be executed, and this data transfer will be there. Did I make sense, or do I sound like cryptic? Do I sound very cryptic with all this diagram? Okay. Yes, because it's very important to understand that on one hand, we are saying that we don't want to transfer the data, right? On one hand, we will say that we will execute map function on the same machine where data is lying so that there is no transfer of the data. But if your data is such that the record you want to process at a single time is on two machines, okay, on two machines, then you might have to transfer that particular part of the record. Okay, April, are you with me? Okay. A question from Sunesh is, anyway, one mapper will process only 64 MB, right? Yes, it's a good point. So let's understand. So when we try to process, right? When we try to process, we try to process things in terms of lines, words, sentences, and customer information, and customer object or images, not in terms of exact number of bytes, correct? Not a number of exact number of bytes. And that's the problem. So when we process something, we expect the data to be logically correct. And while we were storing data, it was ruthlessly cut by HDFS to be stored in a raw manner. Correct. So under the hood, it is basically based on number of bytes, 64 MB. But in the mapper, we do not want to process exact 64 MB. We would like to process the number of lines available on that machine. These number of lines may be a little bit bigger than 64 MB or maybe smaller than 64 MB. Okay, but the tendency would be the data transport that is required to complete the record or line of the record. In our example of word count is same thing. So the data transport that's required to transport that small data in order to complete record, it's it's okay. It's okay because it's going to be very small. So here the below ones, this is the block boundaries. Okay, while these are the input split boundaries. Okay, input split is nothing but kind of a list of records. This is list of records. Yes, input split depends upon the key and the value that we define. That's right, Rahila. A question from Alvin: is there an optimal size of input split and block boundaries? Okay, So this, yeah, the optimal is we try as much as possible to create our input split equal to the block size. Okay, equal to the block size. If imagine that our data is compressed with zip format, right? So those who are from the olden times, they would recollect that we used to split a big zip file so that it could fit into our USB or our floppy disks, right? And whenever we have to combine, we have to generate the actual data, we will need all the parts together. Only then we can unzip it, right? Anybody remember splitting a big zip file and then combining it? So, so imagine that our data here was compressed, right? Let's say in zip format, it was compressed. And when you cut the zip file into blocks, right? And we want to process this zip file. Let's say we want to unzip this data. In that cases, we will have to transport these two remaining blocks to the same machine and unzip it. Okay. So in those kind of cases, in those kind of cases, our input is split. The data we want to process is not same as the data block because we want to process the whole file, and whole file would be on multiple data blocks, correct? So the optimal size is very much optimal size is generally such that the input split is very much similar in size than our data block, right? And like the processing of zip file is a very how should I say, it's a very inefficient, that's not optimal. Okay, therefore Hadoop guys came up with their own splittable compressed format. There's a format called gzip splittable, which basically creates a compressed format which is very optimized and can be unzipped in parts. All right. A question from Manu: who will take care of input split? So there is a program called input format. An input format is a Java class which converts the data blocks into records and hence into input split. Yes. So a question point from Ravi. So we honor input split size demands. So input split is our demand. Okay, that this we want the data to be like this, and extend split data into next block. Okay, keep some empty space when last piece of the data is beyond last full block. Okay, let me try to understand. So it's like this. We want to process data in terms of lines, sentences, and maybe paragraphs. Okay. So whatever you want to process together in single shot, that is generally a record. Like in our case, we wanted to process one line at a time, meaning our map function was getting one line at a time, or our map function was being called for every line. So line was a record in our case. Okay. So sometimes if you are combining thousands of images into one file, in that case, every record might be a single image. Okay. So in order to complete our records definition, we transfer a little data from the other node to this node. Okay. Did I make sense, Ravi? Actually, I failed to understand your question. So we honor input split size demands. Yes, input split, whatever it takes to complete a record, we honor that part and extend the split data into the next block. And yes, and transfer the extra data required to complete the block and keep some empty space when last piece of the data is beyond last full block. Okay, so yes, so split is not a function. Split is sorry, the I would say this one as input split. Okay, I think this terminology is little confusing. It's actually called input split. Okay, this is actually called, it's a logical version of a data block, or kind of a data block is translated into records. Okay, and that set of records is called input split. Yes. Okay, a question from Pradeep. Suppose the HDFS block is cut 128 MB while input format, while, okay, HDFS block is cut into 128, correct? While input format, while converting raw data into input split, transfers small data from other machines. But mapper processes only 64 MB. Not really. Its mapper can process 128 MB as well. All right. There is no such restriction. We can put restriction in terms of memory on the mapper. Memory as in the amount of data it can load into the memory, which is not same as the data it can read and process. Do it make sense to you? A question from Sunesh, is the transfer of the data from one node to previous node is based on delimiter? Generally, yes. Okay, it is generally that way. All right, I'll try to explain this. This is something a very important concept. It is something a very important concept, and I would like to, it's a tricky question, okay? And if somebody, because the input split is a very interesting phenomena. We pay a lot of attention to MapReduce, but we somehow ignore how this magic happens, okay? And what are the bad use cases of bad use cases of the MapReduce? I'll show you this. Okay, so the way it happens is, let's say this would be, say, machine one. This is our machine one, right? This is our machine one. This is our machine two. Okay, and this is our machine three. Yes. Okay, so these are the three machines, right? Having this data block from here to here, correct? And here to here, right? So this is one data block from here till here, then another data block from here to here, and so on, correct? All right, good. Now, what happens is when this data is getting translated into, from raw block into logical one, okay? So let's say we have to translate it into this raw data into input split, correct? We have to translate it into records. Okay, so what would happen is a very interesting thing that would happen. So from the looks of it, it would look as if first it'll finish processing the data from this side till here, and then once then it will inform the second machine, give me extra data, and then it'll transfer the extra data, and then the second machine will start, and then second machine will finish. No, this is not how it's done. Okay, so from the looks of it, it looks like as if first machine will finish converting the raw data into the records, then second machine will do it. If that was the case, then the whole thing will become sequential, and the objective of MapReduce is completely lost, right? Is everybody with me? So it is not sequential. Conversion of data block into input split is not sequential. It is parallel. Okay, so the way it happens is, imagine that on all these machines, on all these three machines, we have three readers. These are three input formats. Okay, these are three input formats, which are basically starting to read their data blocks. Okay, not here, I'm sorry. It is supposed to be here. It is supposed to be not here. Here and here. Yes. So what happens is, it's basically, the general question is, will the conversion of the raw data, if will the conversion of raw data into input split, which is records, the logical data or objects, will this conversion happen parallelly or will it happen sequentially? Okay. So, or it'll be like this, that we convert raw data into some logical form, right? Using a class called input format. So how does input format work? Okay. You will say that, okay, it converts the raw data into records by translating and observing the input splits, observing the separator, new line, etc., etc. And then the question would be, does it happen parallelly on every node or sequentially? If you say that it will happen parallelly, the next question would be that what happens to the boundary? Okay. So if you say sequentially, then the next question would be, that if you say sequentially, it happens sequentially on all the, we let the data conversion happen on the first node, then it starts with the second node and so on. Then what's the objective of MapReduce if it's sequential, right? The whole objective of MapReduce is lost because it's going to take a lot of time to finish reading the data, right? So the answer is very simple. It's very simple. So what happens is, on all the three machines, input format starts. Here there is one input format. These are the Java classes. Okay, these are Java program which starts on every block. It starts reading data block. Okay, it starts reading data block and it keeps on skipping the data. It keeps on skipping the data till it realizes that the boundary has been reached. In this case, since it is starting at the boundary itself, it will say that let me consume data and let's not skip it. Okay. So in this case, it will keep on skipping unless it bumps into a boundary of the record. In our case, what was the boundary? In our word count example, what was the boundary? Quickly. Yes. What was the boundary? Slash n, correct. Slash n was the boundary because you're consuming the whole line in a single shot in mapper function, and this single line was our record. Okay, so the boundary in our word count was slash n. Okay, thank you, Jiankun. Yes, good, good. So the slash n was our boundary. Okay, and so what happens is, it kept on skipping the data. It'll keep on skipping the data till the point it realizes that it has hit the boundary. Okay, a question from Rahela: what if it is a space for slash n? Yes, if let's say if you want to process our data based on space, whether it's slash n slash t or something like that we can configure in mapper. In those cases, you don't have to split. Input format will split the lines and will give you word. All you have to do is print word comma 1 instead of doing any kind of processing. Okay, now so it keeps on skipping this data and marking it marking that this record belongs to the previous machine. Okay, and the moment it bumps into a delimiter, then it starts consuming it. It starts consuming it and keeps on converting it. It starts converting this into a record till the point another boundary has come. Okay, then once another boundary is reached, then it'll create another record and so on. So the records will be created and will happen. And when this one reaches here and it has not detected a boundary, it will ask the next machine, can you give me the remaining part of this particular record? And the next machine will transfer that. Okay. So all these three machines will start reading parallelly, and the logic in all the three is very common. The logic is keep on skipping the data for the previous record, keep on skipping the data and keep giving it to the previous record unless you hit the boundary. Okay? And once you hit the boundary, then it start consuming the data and convert it into record. And for every record, then mapper, the Hadoop MapReduce will execute, for every record, it will execute the mapper function. Okay. A question from Sunesh, but there should be some maximum limit for the reader. Okay. There is the way it happens is reader tries to keep a small memory footprint, and as soon as it reads data, it generally flushes it to mapper. Okay, so generally it does not keep an entire thing into the memory. A question from Srini: is that request to get the rest of the record happening at HDFS level? No, it is happening at MapReduce level. So this class is part of Hadoop MapReduce, by the way, but this class called input format is used by almost everyone. Okay. A question from Saida: how the communication between machine is channeled? So the communication is over TCP. all the data nodes all the data nodes are all the data nodes or node managers are running on a board, and you can communicate with them. Okay. All right, so it's a part of input format and Hadoop MapReduce framework to make sure this translation happen. All right, a question from Pradeep: the input format identifies the boundaries on delimiters. How does the input format know which is the boundary, if it is space or comma? Most of these input formats have that value hard-coded by default. We can customize these boundaries. Okay, we can customize these boundaries. And Sahida's question is, driver does that, I guess. So basically input format does that for us. Kurt's question is how the file is getting split to different machines. Okay, how is the file getting split to the different machines? This was we discussed as part of HDFS. There, a single file is basically broken down into blocks by the client and then capped. Okay, did I miss your question? Or did I understand your question correctly? Question from Sudhakar: what if each record is more than 150 MB? Let it be. Okay, let it be. So the machine is skipping the data from machine 1. So the machine is skipping the data from machine 1 until 3. Yes, so that's what I was trying. So you are saying that machine 1 So a machine 2 will keep on skipping and start processing parallelly. It won't wait for machine 1 to consume the first part. Okay, so machine 2 will basically, all of these are happening parallelly. So while this one is processing, this one is also processing here. Okay, and similarly this one is also processing here. So all these three are happening in parallel. All right. Question from Sunesh. The logic is that if the record is not within a block, read the rest from the next block. Yes. If you have not hit the boundary, then uh, read from the next block. Request the next server for the block. Okay. A question from Kerr. In case of 5, we need to copy the partial line from machine 2 to machine 1. That's right. Yes. Okay. In case of line number 5 or record number 5, we need to copy some partial data, around 30% of the data from machine 2 to machine 1. So a quite very good question from Narendra. Did we implement input formatter in MR code yesterday? Did we use input display at all in the yesterday's class? Very good point, Narendra. So we did not, in the driver, we can specify which which input format do we want to use. But since we did not do, therefore, MapReduce by default assumed text input format. Okay, so it by default assumed that we want to use text input format. Okay, Kurt's question is, uh, split happens as the block max size is reached. In this case, how data can be copied? Okay, split as in, are we talking about input split, right? We're talking about input split. Okay, input split happens as the block max size is reached. So input split is basically, it tries to, input format defines what should be an input split. Generally, input format tries to create input split, which is in a similar size as the raw data. Okay, sometimes input split could be equal to the entire file. Sometimes input split could be equal to the block, and so on. All right. So that part, Narendra, we will discuss now. Okay. A question from, yeah, very good questions coming up. Okay. So I'm copying these entire discussions into the drive folder. So make sure to take a look at the drive. At the top section of the no big data, you will find the link to the drive. Okay, so I've here, you see Google Drive folder for Jan 14 batch. This contains the current folder having all the information. Okay, uh, it will have chat and it will have everything that is required. Yes, there are quite a few interesting questions. Let me answer those questions. All right. Kar, was I able to answer your question? So Kar's question is, the input split happens as the block's max size is reached. Okay, not really. Input split is our requirement. Sometimes we want to process the entire file via single mapper, or sometimes we want to process really huge data together or really small data. So input split is the function of which input format we are using, and in the input format is the class that we would like to use based on our need. Okay. Just ignore this part, by the way. This is a different example, not the same example. Okay, a question from Martian. Use case that you were about to discuss where not knowing this could lead incorrect processing. Yes. Okay. Yes. Imagine that we're processing a data and we are using an input format. So one day, I'll tell you this interesting case. Okay. One day, one of my students, what he did was he created a file by concatenating the file with itself. So he wrote, hello, how are you? And then he concatenated the file again and again. He concatenated the file again and again. And then he was running the word count. It's a real case. So, and I saw this happening with lots of people. So all he did was, I'll tell you what he did. So he created a file, hi, how are you? This was the file without a enter in this. There's no new line. Okay. There was no new line in this file. And what it did was cat file1 into file2, and he kept on doing it for like around 100 times like this. Okay. And after some time, he again concatenated 2 with again 2 and so on. So basically, he concatenated the file again and again with itself. And then he was trying to do the word count on this file. Okay. So, and you know what was happening in that case? There was this weird thing happening, and none of us in the first shot could realize what has gone wrong. Okay. So what was happening is every time he was running his word count program, it was just giving memory overflow. Why? Because why? Because this file did not have a new line. It was half GB file, 500 MB file with no new line. Okay, because he did not press enter in the first file and he kept on concatenated it. So it was like this. The file looked like this. File looked like this. Really, a single line with so much of data. This is how it looked like. Okay, so it was a single line with a huge data. Okay, so when we were trying to do word count, so what was happening is, although the data was in many blocks, but a single record, because it's a single line, there was only a single record, and hence the entire record was being fed to the mapper, and therefore we were getting the memory overflow. Okay. Did it make sense to you? This is a single line actually. If I undo the word wrap, okay, if I say wrap, okay, you see, it's a single line. All right. So in such case, there was a very quick way of getting out of this situation. All I did was, instead of having delimiter as new line, I made the delimiter to be space. Okay. And that's all the problem. A question from Ravi. So when a machine needs last piece of data from another machine, will the transfer occur as the whole block's worth of data or only the part? So it is generally only that part. Question from Srini. Will there be any performance issue because of this behavior? Yes. If we are not unsure about how we are handling, we will get the performance hit. As I just told you, as I gave you an example, that sometimes just because of selecting the wrong input format might kill the entire map reduce. Okay, and even true for the newer framework. If you have not wisely selected the input format, Spark also uses the same mechanism. Spark basically uses input format to convert data into records and then processes these records. This is called RDD, by the way, in case of Spark. This is called Resilience Distributed Dataset. Okay, we'll talk about that when we discuss about Spark. All right. All right. A question, how does the mechanism work with binary data? A question from Srini, how does this mechanism work with binary data? Luckily, most of the binary data has a delimiter inside it. Okay. Based on that delimiter, the data is converted into records and hence processed. Okay. Even if it's binary data, we generally store it with the proper separators. Now, this one, there is a huge problem in case there is a huge file and the whole file is a single JavaScript object notation. Okay, those kind of cases cannot be handled using the input format. Okay, so I'll give you an example. So just for the hypothetical cases. Okay. Okay, I'll give a very good example. This was something that actually came from one of the problems that we were trying to solve for what do you call company here. So they were translating their XML data to JSON. Okay, so in case of XML data, the data will look like this. Okay, so we'll say customer and then the name of the customer, and let's say the name of customer is Srini and name, right? And then customer ended. Okay, let's say your data looks like this, correct? So while processing this data, your input formats delimiter would be what? Quickly, what will be your boundary? So you want to process one customer at a time. Yes, so we'll look for slash customer. Okay, had there been many such XML files, we could have, or many such XMLs, then we could have XML. But generally, a single XML starts with XML, ends with XML like this. Good. So in this case, we can simply say customer, right? And therefore, it'll be all nice and simple. But the problem starts occurring when we have the data in a JSON format. If same thing I have to write in JSON, it'll be like this. Curly bracket here. Okay, curly bracket here, curly bracket here. So my object has ended. And then I will say like this. Okay. All right. Then another curly bracket, name colon Srini. Okay, name colon Srini, and then comma and like this. Okay, so here we go. Now, if you take a look at it, we really cannot, and then there'll be a comma here, or let me just put it like an array. It's an array of our customers, and that's it. Okay, so and it could be like customers equals a list of customers, and that's pretty much okay. So you see, so similarly, there could be many other customers than Srini. For time being, let's just assume that there is only one customer. Okay, I mean, let me just try to. Okay, How do you generally copy these things? Okay, so like this. Okay, all right. So what you see is we cannot really identify delimiter like this. If we say our delimiter here is this in comma. So what would happen is if the delimiter is occurring somewhere like here, that will also break down. All right. Therefore, JSON is not a great format with XML, but the nice thing what people have done is they've started keeping the data in this format, where every line of the data is a JSON object like this. Okay, then new line, then another object. So we have started keeping the data like this. Okay, so that we can simply, so processing this kind of data is like impossible with MapReduce or even Spark. Therefore, you'll find a lot of data these days in this format, okay, where every line is a valid JSON object. Now, we don't have to, we just have to detect new line and that's it. Okay, so what will be the delimiter in this case, the third case, quickly? New line, yes, that's right. It'll be /n. Okay, so basically the idea is that when we are processing data, we should be able to detect the boundary, and input format works that way. Okay, Nitesh's question is, okay, a question from Ravi. This split discussion relates to read data from blocks or even writing the data to blocks. So writing is something which HDFS will anyway do, and we will keep writing to HDFS, and HDFS will automatically redirect us. Okay, writing is generally sequential on per node basis. But this one, basically here we are generally restricting ourselves to reading data from logs. Okay. Nitesh is saying, can you please explain end-to-end flow? Suppose I have a map and reduce function for word count, and I have a text file called log.txt of 2 GB created by a logger on my Windows machine. I will be copying this file to HDFS and then running the map reduce. I want to know who will split the file into blocks and what will be passed to MapReduce as an input file, log.txt or something else. Okay, there are two interesting questions. So Nitesh, let me answer Naren's question first, and then we will come back to your question. These are very interesting questions, and yeah, that's why I want to make a note of these. Okay, so let me just do a wrap. Okay, and the second question that I would like to answer is this. All right, so we talked about the three kind of data formats. One is this, okay, and second is this, and third is this. All right, yes. Let me answer a question from Narendra. Twitter feeds are in JSON format. Does it mean Spark and MR cannot process it efficiently? So most of the Twitter feeds that you will find, or even there is this data, if you go to our data, you know, how do you hide it? Okay, so if you go to, let's say, What was it? D. Yeah. All right. So what you have here is, if you go here, I'm trying to demonstrate the example that we are talking about. So let's take a case of these data sets. Here we have data from, say, object. Let's take a case of, where is that data from Enron? There was this data from Enron. Yeah. So what you have here is, this is a plain text file. Never mind. So okay, not this one. This one is not also that format. Okay, I think it'll be there somewhere here. All right. Okay, so this one is all right. Next is this. Yeah, I'm about to show you this part. So these are the Twitter data, right? And Twitter data is in JSON format. Okay. So here there's an interesting part. What's happening is that every line is a JSON record. This is the Twitter data. This is a JSON formatted Twitter data. It describes like, what does the text contain? Okay, it says, the text says Iron Man 3 crushes opening day records in China, and blah blah blah. So this is the tweet. Okay, and it's going till here. It's going till here, and then another line is starting. See that? So here every line is a single tweet. Okay, which means that our data is in this format, one line per tweet. Therefore, we'll simply use input format as text input format, which means we will get the whole line, then we will convert that into JSON using standard library, and then process whatever the way we like. Okay. In the same way, had every line been a full XML object, it could have been very simple. Do I make sense, Narendra? All right. So that question deserved an answer, because this is a very common question which people come up with, and I mean, others would also get benefited with this. Okay. So whenever we are processing data, pay close attention to what input format are we trying to use. Okay. Now let's go ahead and talk about the first question. All right. So can you please explain end-to-end flow? Suppose I have map reduce functions for word count, and I have a text file log.txt of 2 GB created by a logger on my machine. Okay. So let's just talk about, so who all want this discussion to be done? It's an interesting question, and it'll be important to learn this. Okay, let's start. So first thing is, I have log.txt on your machine, right? Okay, good. Now, all right, let me just sketch it for you. Although I'm pretty bad at sketching, but let me give it a try. Okay, so what happens is, let's say you have your log.txt 2 GB on Windows laptop. Good. So the first thing that you'll try to do is you have to take it till HDFS, right? You have to take it till HDFS. Yes, I'll talk about that, Sunny. Okay, so first you have to take it to till HDFS. So you could either there are many ways I'll explain to you. One is by using hue. This is clear to you, right? By using hue. The second would be that on this machine, on this machine, install HDFS client on your laptop, and use and copy using Hadoop FS copy from local, right? The second would, the third approach would be twofold. One, copy to one Linux console, okay? One machine which is running the data node, okay? And okay, and then use fs copy from local, okay? Or move from local, because you don't want to duplicate data, right? So you copied the data and then moved to the HDFS. This is clear? Okay. The other thing, there is an interesting part. Um, let's say this data was in some other big HDFS, some other HDFS you're using, and you want that data to be copied here. There is a command for that called Hadoop FS. What do you say? We call it dist CP. Okay, it's a distributed copy. Data node of this HDFS will start copying to data node of this HDFS, and it kind of tries to utilize MapReduce under the hood. Yes, all these approaches are clear to you? Okay. Now, so these are all same step. These are step number one, copying the data. This is step number one. So these are alternatives to each other. First approach is this. Second approach is, so this is if your data is in locally also you have your own HDFS running. In that case, you use this CP. If you have your Windows laptop and you don't want to use any other command, you use Hue. And you want to directly copy to HDFS. Sometimes installing Hadoop client, which is Hadoop command, can be very useful, and using Hadoop FS copy from local is quite useful. Okay. And the last one is that you copy to one of the consoles and then move the data. You remember the triangle diagram? So in triangle, we did not have these two approaches. These two approaches, these two approaches were not there. Okay. Can we use putty? I'm not sure, but you can use FSCP. So this is using say SCP or FileZilla, right? So in production time, either you use this approach or you use this approach. We don't use these approaches in production. Or the other approach is to use Flume. Okay, we will talk about Flume at later point of time. Okay, how can I make a diagram like this? Okay, this approach is called using Flume. Okay, if there are many log.txt coming in continuously, in those cases, Flume will be a better option. All right, so this is part of what command would you use? Yes, it's really ugly diagram. So the next thing you will do is understand what would happen here, right? So when the user wants to copy data to HDFS, a client will be used. Okay. Here, when we say Hadoop DistCP, it's a Hadoop, we are directly using the client. When we say Hue under the hood is using a Hadoop client. When we say install this, we are installing client on our laptop. And when we use this from here to here, we are directly using the client. Okay. So the client will talk to HDFS that, hey, we want to store log.txt, and client will direct us. The client will talk to name node will direct us to data nodes, and this log.txt will be in 8 parts. Okay, so it'll have 8 parts in it. Okay, let's just make some parts here. Something like this. There'll be 8 parts. 8 blocks. Let's imagine for time being that all of 8 blocks are on 8 different machines. There could be a case that 8 blocks are on 2 machines because 4 blocks on one, 4 blocks on another, and so on. Okay, a file could have multiple blocks on one machine. It's just the replication will be on different machines. Okay, so this will be, let's say, 128 MB. Correct? If it's 2 GB, it will be how many blocks, by the way? Quickly, anybody? Since it's 2 GB, how many blocks will be there? 16 blocks, correct? Thank you. So, yes, so there'll be 16 blocks, which means 16 separate ones, right? Here, now there is 128 MB here, 128 MB here, 128 MB here, okay? And this block, while we run our MapReduce program, this block of data will get converted into lines, okay, into lines. Let me try to draw some lines, okay. Okay, so it'll have, let's say, some lines, okay, and this one will also have, okay, like this. Good. So this 128 MB will be broken down into complete lines, right? And for every block of data, the mapper will be initialized, and then in the similar way, your map function will be called on every record. Okay, these are lines. So the raw data got converted into line 1, okay, line 2, as in it'll be something like this. This is a brave new world, okay, or let's say, let me just take a typical case of how does the data looks like in the logs. Okay, so this is how our data would look like in the log, let's say log messages. This one, ouch, it's not there. There was a project for Spark, and yeah, here it is. Okay, so like this. So this will be in first record and so on. So this conversion is happening. So this is first line and so on, and there'll be another line. Here goes second one, and so on. So this is the data from our actual file. Now when this conversion, when does it happen? Whenever we execute a MapReduce job, this conversion starts happening. Okay, this conversion that you see on the screen, it's a part of so so what you see in this screen here, this conversion is part of MapReduce job. Okay, this is MR. Okay, this is a MapReduce job. So input format is being executed here. This is the input format class that's converting it. Good. So same input format is getting executed on all the machines parallelly, on all the machines, and converting the raw data into records. Okay, all right. And on every record, your map function is getting executed. Yes, so you have all map functions getting executed here. Good. So this is happening. This one is happening on machine one. Okay, this one would be happening nearer to the machine one, same as this. Okay, so then the output of the mapper will be taken by Hadoop, and all of this I'll try to draw something. Okay, this will go to the output of this will be taken by Hadoop, and Hadoop sorting and grouping. Okay, and then your reduce functions would be called. Okay, your reduce functions will be called, and so on. And then the result of both will be saved into disk. Okay, so I hope that's clear. All right, now a question from Ravi. We have to design and develop these MR program by hand as per custom needs. So not always. 90% of the work can be done by third-party tools like Hive and other Spark, even Hive and say Pig. 90% of the work can be done. You don't have to design these things. But input format we need to know. Okay, we need to know because the selection of input format is something we have to be careful about. Okay. So a question from Ravi. So there are already MR routines available. Lucky for us that some people have written these nice layers on top of MapReduce so that you can simply write SQL queries and rest of this magic will happen under the hood. Okay. So therefore, people in today's time, people only need to focus on converting the raw data into records. And once it gets converted into records, meaningful records, then we can process using Hive or maybe Pig or something like that. Okay, a question from Srini. Is it grouping happen before reducer? Yeah, basically before feeding the data to your reducer function, Hadoop is doing that, although grouping happens on the same node as on which the reducer is happening. Okay, before calling your reduce function, the grouping happens. This happens on the node which we call our reducer node. All right, so this, let me just keep this somewhere. Okay, and anyway, you can take a screenshot anytime from the video. Okay, and yeah, great. So I hope that clears all our doubts about input split. Okay, so again, the same thing whatever we've discussed. Hadoop divides input into pieces called splits. One mapper instance per input split. For the entire mapper, the entire set of records, it creates only one instance of input split, one instance of mapper for the entire input split, so that it doesn't have to keep on creating instance. It is like initializing the mapping process only once and calling it many times. Okay. Okay. A question from Nitesh. So the client or the user will be invoking mapper reducer by giving log.txt as the input. They don't need to bother about how the log.txt being distributed over different machines. No, they don't. That complexity, whether log.txt is on 20 machine or 100 machines, it is taken and absorbed by Hadoop MapReduce. Though Hadoop MapReduce limits you on what you can do. Let's say what you want to do is that on the second node, do this, and on the first node, do that. You cannot write a logic like that. Okay? So that kind of control is not there because that complexity is hidden from us. But you can write logic like this. If the line number is greater than this, or the byte count is greater than this, then do this. If you observe that the input data is like this, then do that. So that kind of control you have, but specific to a node, it's not there. Okay. And it should not be there generally because you do not know anything about runtime. Your program could be running on 2 machines, 3 machines, or something, depending on the data and the circumstances. All right, back to the input splits. Hadoop divides the data into pieces called splits. One mapper instance per input split. Split consists of many records. Map runs on every record of split. Small split means if there are very small input splits, there will be too much of overhead of transport, right? If there were input format is creating, say, 1 MB of input split, okay, then there will be too much of overhead because there will be too much of transport of data from one machine to another. And good split size tend to be equal to the HDFS block. A question from Pradeep. If we have space in the delimiter, okay, then in somewhere or in many places we have spaces in the data. So how will input split be split correctly with the entire meaningful data from multiple data blocks? Okay, let me think for a moment. Um, if we have space as a delimiter, okay, and then in somewhere or in many places, we have spaces in the data. So how will input split be splitted correctly with the entire meaningful data from multiple data blocks? Okay. So if the if we break down, okay, let me think. Okay, so good question. So if you have a space as delimiter, so the questions like word count can be solved very well. Question like word count can be solved very well. Why? Because there, in our map function, instead of trying to process the line, you will get a per one word per line. Okay, one word per mapper. So you don't have to break down the line per space. We don't have to break down the line for by ourselves because input format will do that for us. Okay, I hope that answers your question. All right. So input split is nothing but bunch of records that get created by input format and from the raw block. Input split is further divided into records. Basically, input split is bunch of records. A map function is applied on each record. A record is a very logical entity. It is very analogous to the row or a line in the plain text. Input format creates records. Okay, so there are many available input formats. There are many available input formats, and the usage goes like this. So we can, the job variable that we had, which we use for setting driver as well as mapper as well as reducer class. So we can set the input format on the job itself. We could say that this is our input format class and so on. So by default, it is text input format class. That is the default input format. Okay, let's say you want to make sure that each input split have exactly equal number of lines. Then you can use another input format called n-line input format. Okay, there we can also set variables like this. If you see the example that we discussed yesterday, the GitHub one. Okay, so there are quite a few examples here. So here there is one like custom reader. There we have implemented our own custom input format. And then we have stub mapper, stub driver here. So here in this line, you can see that this is how you set the custom input format. Let me increase the font. So we set the driver, we set the mapper, we set the reducer, and we can also set our custom input format. We are saying that uh, please use 1000. The plus is wrong here. You have to remove plus here, and this is also wrong. Okay, these two lines, two characters we have to remove. Okay, so and this is commented by the way. Similarly, if you want to, if you know that your record, okay, record is of fixed length. Okay, so yeah, a question from Raila that there are some input files from Java required for setting the job. Could you please list it? So these are generally ones. So use these ones, okay? Remember that if you have MapReduce in this, that is generally the newer library, Hadoop 2.0. If you have MapRed like this one, you see this one. This is the older library, okay? That's why this conf is kind of deprecated. It keeps giving, so you can actually remove and use the newer syntaxes. Okay, so is it clear to everyone? All right, so this is how you generally set the configuration variables. So I'm going to list down these All right, we can use Hive instead. We can also use Hive for many use cases. All right, the other input format is fixed length input format. So Hive also uses the same mechanism, input formats under the hood, and sometimes you might have to instruct Hive to use a particular input format. Okay. All right. So sometimes your record, your data is of fixed length, right? There are many formats in the industry where we know for sure that every record is going to be 1,000 bytes. There is no separator like /n or /r. It's just this fixed size. Okay. So you could also use that. Okay. If you are setting using fixed length input format, you can set the record length by using this kind of a format. And this all setting happens inside driver main method. Okay. Sometimes your data is in key value, so you can use key value text input format. By default, key value pair is separated by equal. Okay. And the key value pairs are separated by new line. One key value pair is separated from another by new line, and key and value are separated by equal sign. You can change by setting this particular variable in the conf object, the way we had shown. And then comes sequence file input format. Sequence file input format is nothing but binary data. Okay. It can have binary key value format. Binary key value format. What does it mean? Every record in case of sequence file input format is a pair of key and value. Key is it can be string, can be a binary. Value can be string or can be a binary. Okay, so what the sequence file input format is very interesting one. Okay, sequence file input format was designed purposefully. It was designed purposefully for HDFS. It was designed purposefully for HDFS. Okay, so the way we generally handle a large number of files. So what we do generally is, let's say you have 1,000,000 files. What we'll do is we'll compress these files, combine them together, and use sequence file format for storing such file. Okay, so we basically use sequence file input format as as a replacement for jar, tar, or zip. Okay. So an archive is generally converted into sequence file. And when we process such sequence file, what happens is the key is the name of the file and the value is the content of the file. Okay. For small files, you can combine them together, keep it in sequence file, and then process using input format called sequence file input format. So there was one question which I had skipped earlier, where what happens in the case when the data is image or binary. In all those cases, let's say you want to process music, you have 1,000,000 music files and you want to do some kind of analysis. Let's say you want to compute beats per minute in every song, or maybe you want to do some other analysis. So generally what we will do is we will combine all these files together into a sequence file format and save it in HDFS, and then use and sequence file input format to convert those sequence file input format while using our MapReduce engine. Okay, okay. And also, even if you plan to use Hive, you can tell Hive that, hey, my data is in sequence file input format, and accordingly, please handle that. Okay, so under the hood, it'll do that. Sunny's question is, what about password protected files? So generally, when you're converting those password protected files, you use the you basically use a command to convert the zip file into sequence file input format. At that time, it might ask you for password. So quite bigger question from Sunny is probably that what happens for the encryption? Okay, what happens for the encryption? The general way of tackling encryption is that each data block can be encrypted individually, but I think there is another input file format which there's a sequence file, encrypted sequence file format that can be used. I'll have to take a look at that. All right. Okay, so this is so yeah. So there are many input formats. The good news is that across the globe there are hundreds of thousands of engineers who are working on Hadoop and who are working on these input formats. And every now and then, so you will always find the input format for your kind of data. Let us take a case. Let us take a case that we realize that we want to process XML data, right? So you'll say, look for XML input format. Okay, so you get this particular answer. So they basically are using one input format developed by Mohawk guys, and that's quite useful. Similarly, let's say you come across, let's say GIS, okay, geographical, okay, what do you say? Um, there is a term. I'm forgetting the term. For survey, right? So GIS input format for Hadoop. Okay. So so basically there are tools for everything. There is this, yeah, this is the one we were using. Okay. So it's called spatial Hadoop. Okay. It's a spatial Hadoop. It contains the input format for Hadoop. Okay. It contains input format for Hadoop. All right. And so when I was talking to one of my students was basically what is a research scholar at National Laboratory, which is part of NASA. So we were looking at their problem and we realized that they needed a format for handling their data. And luckily at that time, we realized that special Hadoop's library are sufficient for us. Now it has become an entire beast, but that time it was just a couple of libraries here and there. Okay, so yes, all right. So you can actually just search for whatever data you are trying to process, like JSON input format for Hadoop. Okay. So here there'll be all kinds of discussions, and okay. So it is going to be decently difficult, even though people try, trying to create JSON format. So here it tries to basically explain that how does it break down. Okay, so it's breaking down based on some ID or something. All right. So they try to create. I mean, creating a input format for JSON is going to be difficult because of the reasons which we again. Similarly, there would be more. Yes, somebody has unmuted himself. Okay. All right, so that's pretty much about the input formats. All right. Okay, so yeah. So Hadoop as well as Spark. I mean, the yarn actually provides the speculative execution. Speculative execution is that if you have like a big team, ask, let's say, you have a task. Okay, you had like three tasks. So you assigned one task to the first task tracker, second to second, and third to third. Okay, and and fourth one to fourth. Now, all three of these finished, fourth one is stuck. So what you'll do is you'll execute the same task somewhere else as well, okay? And let it run parallelly on both these machines, okay? So whosoever finishes faster, their results will be considered. Here, there is a duplication of efforts, but overall, it might take less time, all right? So in our case at Amazon, we used to have, you know, same product being built by multiple teams, right? And whosoever wins in the A/B analytics gets the output. Okay, it was pretty simple. For example, the Amazon's detail page, one of the app was being created by two, three different teams, and mine has won the one which I created. So that's being used right now. So in the similar way, the task 4 is given here to multiple teams. Whosoever finishes faster, their results will be considered. Okay, a question from Sunny. Is there any concept of caching in MR? Okay, so caching as such, MapReduce does not provide. The caching that MapReduce provides is called distributed caching. What does it mean by distributed caching? When the task is being executed on a particular node, some amount of data is saved on that disk. Like, like for example, we are executing a Java program here. So before the Java program gets executed, lot of libraries need to be set up on all. Okay, lot of libraries need to be set up on task 1 and task 2. Okay, as well as on all these four. So this setting up is called distributed caching. Okay, it's not really caching, it's basically copying the data or the code to all the machines. That's all. Okay, so sometimes if we have, let's say, a small amount of data that we want to take to all the machines, we can bundle it together with our program and take it there, and then inside our program we can read the data from that file. That's generally called distributed caching. Okay, so Hadoop MapReduce provides distributed caching whenever we want to take small amount of libraries or small amount of data to every node. In those cases, we use distributed caching. Okay, the caching as such, what does it mean by caching in a lot of places is that um, there is some framework where we put the key values and they can be reused later. So that kind of framework is not provided by Hadoop, but you can use your own caching framework, okay, which is mm, like, let's say you have installed the central memcache. Memcache is one tool which does the caching, and you can use that one. All right. A question from Raila is, what if it crashes with the execution timing? Okay. I did not get. So let's say the task 4 has crashed, right? Then this one has crashed on the task tracker 3. Then task 4 will continue, and the output will be con consumed. If both of these, you know, uh, uh, I mean, both of these clashes. Okay, you mean to say clashes? What if it clashes with the execution timing? Okay, meaning both the tasks have finished at the same time, right? Either of the results will be picked up. All right, either of the results. Okay, so is this speculative execution only for long running tasks? Yes. Generally, we don't keep turn on the speculative execution in yarn, but it can be turned on in case where you really get greedy. Okay, in case you want your task to be executed immediately. The downside of speculative execution is if, let's say, your task 4 is reporting to a central service. Okay, task 4 is reporting to a central service, and this one also. So there'll be two times the same thing is getting reported to the central service, and therefore the output of that central service will be wrong. Let's say we are logging the activities into a database. So task 4 is also logging, and task 4 on tracker 4 is also logging. So both of these are logging, and therefore they'll be double the log. Okay, we'll talk about it again when we talk about Spark. All right. So data locality, this one which we have discussed already. So the best case scenario is A. So let's imagine that you have a nice data center, and you have these three racks are Almiras, and these racks have computers. These computers are in a network. These are all in networks, and then they all are connected by a router, so that there is three switches, 1 2 3, and then there's a fourth switch that connects all three of them. Okay, so racks are basically places where we put the computer. Racks have also the holes in which you can plug in the network cable, and which means that every rack is also having a switch. Okay, so that's it. And so the best case scenario is the data as well as the code are being executed on the same machine. Okay, map task is executed on the same node as the HDFS block. And second case is when the data is on some other node and the execution is happening nearer to the node. The worst case scenario is the data on one rack and code on another rack. In that case, there'll be too much of network transport. Here there'll be a little network transport because all these machines are in a network, in a small subnet. Okay, there are two questions. Let me answer Elvin's first. Does the task tracker 3 start from the beginning of task 4, or just picks up at the point where task 4 was? Okay, no. There is no concept of picking up in midway. Okay, it's a very good question. And so the idea here is the task 4 doesn't know anything about, but task tracker 3 doesn't know anything about task tracker 4. And therefore, task tracker 3 starts from the beginning. In this, in the similar case, in case task tracker 3 had died after finishing this much work, and the same work is being executed on some other machine, what would happen is the entire thing from the beginning would get executed. It won't be partial. It would not be partial. All right. Okay. So yes. All right. A quick question: can reducer take benefit of data locality optimization? Yes. No. Can reducer take benefit of data locality optimization? Data locality optimization means accessing the data on the same machine. Reducer reads from all the nodes, correct? Reducer gets data from all the nodes, and therefore it cannot take the benefit of data locality optimization. Okay, quick question. Yes, no? Who can answer this? Okay, so the first one will be on the local node, second will be on the same rack, and third one will be off the rack. Okay, this we have discussed already. The other question that people ask me that how does map Hadoop? How does Hadoop look at your network topology? Okay, so Hadoop is always configured to look at our network like a tree. Okay, so here these are three machines which are capped on the same rack, connected via rack switch. Similarly, rack 2 is also having a switch, and they are all these three machines are connected there, and these two racks are connected by a switch. Okay, so this is our network topology. And how does Hadoop look at it? Hadoop thinks every node like a folder structure. So this one is slash S1 slash R1 slash N1, and similarly slash N2, N3, and here R2 slash N4 and R2 slash N6. Okay, so just like folder structure, it basically keeps it this way. Okay, so this is called rack awareness. Okay. So the very easier way to create your own way of representing every IP address as a folder structure is by using this configuration script. Okay. It basically converts this kind of IP address into this kind of model. All right. Mohsin's question is, uh, data center is active active or active passive. What does it mean? Sure, Ravi, sure. Okay.
Okay. Sandeep, my question is, if we have two geographically located two different data centers,
Right,
and we have multiple nodes on one data centers,
right.
how the data would be distributed across two data centers? Well, whether one data center will be active and the second would be a backup, or both will be active.
Okay, good question. Good question. So here question is that would we just here question is like this. So when we store data, do we only provide write-only access on one node, on one of the data center, or we also let the other data center participate in reading of the data, as well as do we want the other data center to participate in computation? Okay, so let me try to answer the first question, that whether the second data center can stay just passive, as in you keep on writing to it but you never read from it. That's not possible in case of Hadoop. Okay, but what is possible is, let's say you just want to keep the other data center for not executing anything. In those cases, what we do is we do not execute any node manager on that machine. Okay, basically that machine does not participate in yarn while it participate in HDFS. That makes that one passive. Did I answer your question, Mohsin? All right, great. A question from Nitesh. I was under the impression that Mapper will be running on the same machine on which we have corresponding data. When does it happen that Mapper and the corresponding data are on different machines? Okay, good question. So this kind of thing, the use case like B and C are very rare, right? This is what Hadoop prefers. So it will first try to, so every HDFS block will have 3 copies or maybe more or maybe less, right? So first it will try to execute on the same machine where first copy is there, then second copy and the third copy. And if all the 3 nodes on which the copy is existing, if all the 3 nodes are busy, there is no space of no memory available, or too many tasks are being executed, yarn would not execute your task on the same machine as the replicate node, as the node which is containing the data, right? In those kind of circumstances, it will first try to execute your code nearer to the data, as in on the same rack. If that also fails, then it will try to execute on the different rack. So you can clearly see that the case A would be true in 99% of cases. Case B will be for the rest of 1%, and case C is totally negligible scenarios. Okay. A question from Naren. How are B and C scenarios configured on the nodes? We don't configure it this way. Yarn automatically does that. Okay. We basically define that these nodes are in this rack, these nodes are in this rack, and these racks are connected in this data center. And how do we do this? By translating the IP address into the folder structure, like this. Okay. By creating a script file which will translate the IP address into a folder structure. And once folder structure is ready, then Hadoop can find the distance between the node and accordingly tries to optimize the data transfer. Okay, so the distance is counted as distance from the parent. Okay, distance is counted as distance, total distance taken from one place to another. So node 1 and node 2, the distance is 1 plus 2. Node 1 and node 4, the distance is 1 plus 2 plus 3 plus 4. Okay. So a quick question. In first case, what is the distance? So there is a data center 1 containing one rack 1. Inside that there is a node 1. What's the distance between node 1 against node 1? Quickly. 0. That's right, it is 0. Okay, what is the distance between node 1 and node 2? Going back to the diagram, node 1 and node 2. Yes, again, node 1 and node 2 will go till the common parent and then come down. 2. That's right. So the distance from node 1 and node 2 is 2. Now, you have data center 1, rack 1, and rack 2. Node 1 is existing in rack 1, and node 3 is existing in the rack 2. So, what is the distance between N1 and N3? Correct, it is 4. Right. And what's the distance between in the last case? In the last case, this one. So, we're going till there are two data centers, D1 and D2. They're connected, and no, in the last case, it will be 6. Thank you, Sudhakar. Yes, you can see this. All right. Okay, so thank you, everyone. This concludes our MapReduce discussion. Okay, and yeah, if you have any questions, please feel free to drop an email. Yeah, question from Srini was regarding Eclipse. Eclipse ID, we don't provide Eclipse ID because it's not possible to run Eclipse on the server. But what you can do is you can use Eclipse ID, compile your code, and once that's done, you upload to the server. Okay. Also, anywhere in the world, never ever try to install the Visual Studio or Eclipse or any kind of heavy duty editors. The result of Eclipse The result of Eclipse is a jar, a bundle of your code that you can upload to your Linux console. For that, you can either configure Eclipse to upload, or you can use SCP, WinSCP, FileZilla, or something else. Okay. Yeah, George, can you see the slide? All right, wonderful, wonderful. So that concludes our session on MapReduce. All right, we had to take a break. Okay, so break time. Break for 10 minutes. Back by 10:03 p.m. 10:03 p.m. IST. Okay. All right, so I'm back. Should we start now? All right. There are two questions from Tegu. Okay. So yes, you are right. We could define space as a boundary in that case and could solve that problem. But we had to change our mapper code in those cases. All right. That was one way to deal with the scenario. Okay. Although even if we did not change the mapper code, it actually worked luckily. Okay. Because the logic was like that. Okay. So secondly, so the raw data from HDFS is split by delimiter that we define. So yes, when we launch a mapper process, every time we launch the process, the raw data will be translated, okay, from HDFS into records using that delimiter. Okay. Delimiter, or there could be further more processing because input format could be fairly complex. Like for example, when reading the RC file, the file in which the sequence file which we talked about, binary key value pairs. In that case, the translation is little more than just splitting based on a delimiter. Okay. So yes, in both the cases, your understanding is correct. All right. So, Tegu, did I answer your question? Okay. Good. Good. Very good. And yeah, should we start now? So, how can we debug MR code? Okay, a quick question from Sunny. One way is that you write the test cases and you debug the test cases independently. But if you want to debug the code in production environment, then you might have to kind of depend on the logs. Because MR code runs on many machines simultaneously, just like threads, it becomes little tricky and difficult to debug MR code. Therefore, one way is you run it in the test, you run the test cases. Okay, take a look at the test cases what we have created. If you have created the test cases, you can actually run inside Eclipse itself and debug it stepwise. In the cases where you want to do it in production, you will have to rely on the logs. You can create logs, as in you can say printf uh, sysout dot error dot something, or you can simply create logs, and those logs will come out in the MapReduces logs. Okay. Yes. So if, yes, the case that you are saying, Sunny, in those cases, actually the test cases are quite useful. Okay. Point from Mohsin, if we don't have Ambari, other way or port to see console. Okay, console is completely independent. Console is something that we have done. It has nothing to do with Ambari. Okay. You can actually, using console, you can actually do whatever Ambari is doing for you. Okay, so that way. All right. So should we start with pig and pig Latin? All right. So we are going to keep the session on pig and pig Latin very brief, and we are going to try to jump into the real example instead of talking theory. All right. So I'm going to skip through a lot of content because we have cut down pig a lot because we don't need pig and pig Latin too much in the industry. Most of it has been replaced. Okay. So we would like to, just get used to the basics of it. So it's basically an engine that executes data flows in parallel on Hadoop. Okay, theory wouldn't make sense right now. It runs on Hadoop. It makes use of both HDFS and MapReduce. Okay, probably this is an example that will make more sense to you. Here we have lines equals this. You see, we are saying lines are loaded using this command. Okay, lines equals to load this file as this data type. Okay, which means lines will become a kind of a huge table containing a single column. Okay, then we are saying iterate over the lines and generate and break down into the words, and then group it, then compute the counts. Okay, so this is how a pig program looks like. It is more like stepwise SQL. All right, let's move on. So Pig Latin is a data flow language in which we write our code. So in MapReduce, you have a lot of control, while in Pig Latin, you have less control. Pig Latin provides you the high-level construct just like SQL, like join, filter, group by, order by, union, and so on. Okay. So Pig Latin makes the life very simplified. Pig Latin is great for semi-structured or structured data, and MapReduce is great for doing anything. Just that MapReduce is too much hard work. Okay, Pig Latin can be used as ETL and for researching data and iterative and batch processing. So there is a philosophy of Pig that it can handle all kinds of data and is for parallelism. Okay, so let's get started with CloudX Lab. Okay, that will be a better way of getting started. So please open your console, everyone. So Pig is the engine which executes Pig Latin. So you can say that Pig Latin is SQL and Pig is the SQL server. Not server, SQL, how should I say, SQL executor. All right, so I'm going to SSH into this. I'm not using the console because I need browser as well. Okay, so I have SSH. You can open the console, the web console. Okay, everybody has logged in? Yes, no. So open the browser, click on console, and then key in your login password, and it'll open the web console. Yes, great, great. All right. Okay. So at the same time, let's just open Hue as well. Okay. I'm opening Hue. Why it's not hiding? All right, never mind. So yes, pig Latin under the hood are converted into the MapReduce. I'll show you that, no worries. Okay. So here, is everybody logged in into console? I'm starting pig here. All right. So what you see is that we have logged in into pig. Parallelly, let's take a look at some data. Okay. So let's take a look at, say, some data for, let's say, let me go up, data, and let's take a look at this file. Or maybe let's take a look at this file. Good. So this is our file. I'm going to load this data into our pig. So let me call it nyse diffs equals load. Okay, as maybe I have a record upfront ready. I can do that. Okay, so this is one, and then I can just take a look at dump diffs. All right, so in this command, we are saying that load this data as these 4 columns. Okay, as these 4 columns. So let me minimize this, minimize this, and minimize this. Okay, so what you see is we are saying load this data, okay, as name, ticker, and date and values. All right. Okay, so we loaded the data. There are a few interesting things that would be needed to execute. So here we are basically trying to just load the data and print it. So what you see under the hood is it's actually executing as MapReduce. So instead of you coding MapReduce, it is the pig Latin that, okay, so you can see that it has printed the data. See, it's printing the records. A question from Sunny is how to skip the column from the file. That's for that you will have to use for each, and then you can create another data set. Okay, good. So do you want to try this? So we loaded the data, and the important part what was here, there were few things you will notice. One, nothing happened when we said divs equals to load. It basically noted that you want to load it. It did not do anything much. It basically made a note of it, saying you want to load this data as this, right? But when you said dump divs, only then some action happened. If you see here, no log has been printed when, so we started this and okay, go up. Yes, here pig is getting started, and then you see here. Okay, now where did it go? Just a second. This is called screen blindness. All right. Yes, and there. So here, Where is the dump happening? Yeah, here, you see? So when I said load here, nothing much happened. But when I said dump, only then it did something. By default, the delimiter is tab. Okay, we can change the delimiter. That's not a worry. Okay, so what I'm trying to show you is it does not really load anything into the memory. It just makes a note of it that you are trying to load something. Okay, so everybody is able to execute the command. First type pig. Once the console comes up, then type this command which I had copy pasted. Dump is like print statement. Good. So Tamika, are you stuck somewhere? You need help? Okay. Okay. So you are executing this command on the shell. You have to first execute pig and then copy paste the same statement. Okay. Yes, let me keep the command page on. Instead, I would suggest that I'll keep my console on so that we know exactly what are we trying to do. Okay, so here is my console one. So you can see that the grunt is where I typed my command. Okay, these are the commands. I'll keep both the pages on for you. Good, good. All right. I think this is the right way to learn, that first we do and then we listen to the theory. Okay, because now somebody has said that on what basis it's splitting. So that means, I mean, there are a few questions that are very interesting. All right. So yeah, it's not, yeah, there is one grunt, which is a JavaScript task runner as well. And this one is a prompt of pig, because sorry, the pigs grunt a lot. Okay. So that's why. Shudhakar saying that it's taking long time to display the data because running the MapReduce. Is printing any text? Here I have not here I have not entered. Okay, I have not pressed enter. That's why it's not displaying. Okay. If I press enter, then it will start working. So for you, is it taking too much time? I see. Maybe there are too many jobs running in parallel. Maybe that's the reason. Okay. Or maybe you can just exit and then. All right. So this is how we get started with Pig. Okay. So Pig provides all kinds of syntax, just like SQL, joining the two data sets, grouping the data set, and ordering the data set, selecting few columns and removing others, computing the columns from another, and so on. So Pig basically is a newer version of SQL, but still a lot of people like SQL more. Okay. All right. So that's okay. Now here I'm going to go ahead with, because RESTful theory is kind of okay with everyone. Hive is preferred because people are used to SQL, and uh, SQL is more complete than Big Latin. Okay. Why we are talking about Pig then? Because at a lot of time in industry people ask about Pig, and Pig as a theory is quite important and nice because Spark SQL, sorry, Spark has been modeled. Spark is a language, or the syntax has been modeled like Pig. Okay, we'll talk about that part. That's very important part. How Pig is similar to Spark in many ways. Yes, I did start that way, but some of the people are still liking it and using it. Therefore, we need to learn it. All right. Okay. So here we are, and let's say that there is this data that we need to load and group it. Okay. We need to group the data. For example, here is our data set, and we are trying to compute the average value of the particular stock. We want to compute the average value of stock. Had you been had you been using MapReduce, you will have to first load this file, create a mapper that will print out the key as this, value as this, and in the reduce, we will compute the summation and divide it by the total numbers. That's how we will compute the that's how we'll compute the average value of each symbol. Okay, each ticker or symbol, right? In here, it's pretty simple. First, define your data set by using divs equals load this. And then we say that group equals group data by ticker. Okay, we are saying that group the data based on this. Here, in the next statement, we basically aggregate. In the first one, we grouped and then we aggregated. Yes, in lots of cases, you can actually write Pig Latin very quickly and get it done. Okay, and then we will do this. The only reason why we like to learn MapReduce is, one is the basic infra, as a basic, because under the hood, Pig is also doing MapReduce. Second, lot of problems in real time may be the problems which are not yet solvable using Pig or Hive. Okay. All right. So now let's try to execute this. Here we are saying first load the data, then group the data, then compute the average of each group. Then we are saying store the data into this file in HDFS, and then we are saying print the data. Okay. You can either use hue to check the file in the HDFS, or you can execute this cat command from within the pig prompt. All of this has to be executed on the pig console. Okay, good. So let's try to execute it. Okay, so I'm going into pig. Yes, Narendra, I'll answer that question. The same important question. Let's try to execute this one. And so you see that the MapReduce got executed only after we said, just a second, actually did not get executed. I'll show you why. So first we load, okay, we load, good. Second, we group, good. Then third, we compute the average, good. Now let's try to store. Let's see what happens. It says that the file already exists, you see. It says the average already exists. Let me just delete RM. Okay, or RMF. There is a command called RM. So you see this HDFS commands are also provided by Pig on this console, and using that we can, okay, this time it's doing something. You remember earlier also when we tried to execute MapReduce, it gave an error if the output was already existing. Okay, so it has saved the data. Let's take a look in Ambari. And the way I'll do is I'll click on home, sort the data by timestamp, and then you see there is this average folder created recently. It's exactly in the same format as our MapReduce. And here is the average value of the stocks. You see, are you able to execute it? Yes. What kind of error are you facing, Sunny? You want me to take a look? So this is the command that we have executed. Okay. All right. Okay. Try. Sahida's question is generate group statement calls MapReduce, and Naren's question was that why is other things executing when we are saying store or dump. So if you noticed, when we said dump, only then things happen. Similarly here, the moment we said store, only then the whole process started. It started showing the logs, it started doing something and taking time. Earlier, when we executed all these three statements, it instantaneously happened as if nothing has happened. Actually, nothing much has happened. Only the main work, the process gets started when we say dump or store. Here is as if we are just coding. And in the fourth line, the moment we execute the fourth line, it is as if we have submitted our job, MapReduce job. Okay, so that's the way it is. So Pig basically keeps making a note of things as you are defining them. And the moment we say store or dump, it evaluates all the data set, all the data set on which your current data set is depending. I'll explain why. For example, we are saying store averaged. Okay. So what is averaged? Average is this for each group. Okay, which means averaged depends on grouped. Now grouped depends on divs. Divs depends on this file. So all of this will be computed when you say store. When you say store, it will find out what all needs to be done, and then it will create a MapReduce job out of all the things that needs to be done. And under the hood, it will execute that job. While store stores the data in HDFS, dump prints the data on the UI. Okay, dump prints the data on the user interface. Okay, does that answer your question, Sahida, Narendra? Yes, these are our variables representing data sets. Divs, grouped, averaged are the variables. These all three are our data set that we are defining. These are not really data set because they are just instructions. Had this been data set, it would be loading all the file into the memory, which is wrong. Here, it just makes a note of it. Divs represents this particular file. Group, grouped represents this particular instruction, and averaged represent this particular instruction. Okay. Okay, so you can go to home, click on home. Here, when we are saying store averaged into HDFS file called averaged, this is the name of the data set. This is the name of the HDFS file. So when we say store here, it is basically storing data here. Okay, so go to home folder, you will see in the home folder. Click on the file browser first, then click on the home folder, and then you will see the file. Ravi? Yes, dump would not store data. It will just print on the screen. Question from Naren, I still don't understand. The input file reference is clear and is stored in HDFS. So why execute MR for display? Correct. So if we are trying to do this, it's actually totally useless, right? But if we are trying to, you know, do this, do this, do this, and we could say here dump avged. Now, do you think it's useful? All right. So instead of storing, you could actually print on the screen. Great, great. All right. Any questions at this point? So this is what a typically a pig Latin script looks like. It's like SQL, but we have broken down a huge SQL into statements. Okay. So all of the slides and everything along with the previous session's video is available in LMS. Please go through it. And I think this is a good enough introduction to Pig. Okay. All we did was we loaded input text file as dataset, and then we used the other. Yes. In the slides, you will find the entire Pig statement. Okay, we used to cover pig in a greater details, and I think it was most exhaustive course on pig available, and but we have recently dropped it. Okay, all right. So I think this is a good way to starting it. And if you want to dig little more, you can go further deep into the course. If you specifically wanted to learn pig, then feel free to drop me an email, then we can have a quick session on pig. All right. Okay. A question from George. Are we storing the value of ticker into grouped? Are we storing value of ticker into grouped? Not really. So here, divs represents the entire file. Okay. NYSE dividends. You can check this data. And grouped represents the data which is grouped based on the second column called ticker. This data got grouped by ticker. Then we iterated over the data. We basically said for each grouped and generate the group. Group is the name of the column on which you have grouped the data, and and the average value of the columns which have been grouped together. Okay, and then we are dumping it. We're printing it or we are storing it. All right. Yes. Any questions at this point? Yeah. So why is pig dropped from the course? Is there a better? So generally, people either use Hive or we will put all the energy into Spark. Okay. We'll put more energy into Spark and Hive. All right, so that was quick introduction to Pig. Pig has all kind of complex data sets as well as simple data sets, and it has you can understand how to customize loading the file, as well as you can understand how to you know, customize the way you store data, then how to use for each further, and if you want to just select few columns as um, someone was asking, you could use for each with generate syntax. Okay, so you can basically take a look at the course. This says how do you group by something, how do you flatten it. Flatten is opposite of group by. If you want to filter certain records, you can use filter, and so on. Okay, if you want to uh, remove certain elements from it, you can use filter. Okay, you can do the joins. You can you have left join, right join, and a full join. So it has entire syntax for everything, the everything that SQL can do. Okay, all right, so this is our pig Latin, and let's continue with our discussion on Hive. All right, should we? Yes, yes, you can do that, Sunny. You can skip a column using for each. All right, wonderful. Okay, so that was our quick introduction on pig, and I'm sure it'll be sufficient for most of you. If you are going really for an interview at pig, just go through the presentation, the slides, and the video. That should be good enough. Okay, we have exercise on pig and pig Latin, subjective and objective both. You can try that. All right. So Samit's question is, with respect to the mapper classes, do we have to define them, or is there a full list available? You will have to generally define it. You'll have to define your own mapper class and extend the mapper. Okay. What is available is the input, various input formats. Okay, as well as various kinds of the value formats such as long writable, int writable, and others. Okay, so let's start with our Hive discussion. All right, so Hadoop is great. Hadoop is great, as well as MapReduce is great. MapReduce is great, but how do you move existing relational data and SQL infrastructure to Hadoop MapReduce? There are huge SQL users as well as DB designers and administrators. How would you move them to writing MapReduce? MapReduce is even difficult for people like me. Okay, if you somebody throws suddenly a problem about, let's say, some complex mechanism, say, as I was telling you that matrix multiplication, it took me a decent amount of time. It took me more than an hour to figure out and solve that matrix multiplication using MapReduce. So MapReduce is little difficult even for developers. Second, in MapReduce, there's a lot of repetitive logic. When we could just group by things so easily with SQL, why should we be writing code for the same thing, right? This is where Hive or Pig comes into play. So the value proposition of Hive is it is mostly suited for data warehouses. It is suited well for data warehouses kind of scenarios where relatively static data is analyzed, and we do not require fast response. And Hive makes it easier to port existing projects, and it provides an SQL dialect called Hive SQL, Hive QL, and it maintains the metadata in the meta store. Okay, what does it mean by metadata? So if you take a look at what we just did in Pig, we loaded this, we defined this data set, we loaded this, and so on. But if you exit the console and then restart it, those data sets are gone. They're no longer there. Therefore, in Pig, you will have to define the data sets again and again whenever you require them. Okay, while in case of SQL, when you define a table, it remains there. It remains there, available for us. Okay, so that's the difference between Hive and Pig. Yes, Hive will be converted into MapReduce under the hood, just like Piglatin. Okay, so all the table that you define once are available next time again when you open Hive console, as well as when you next time come back to the Hue. Hive will be available. All the tables will be available in Hive. Okay, so so this information, like what table have you defined and what are the columns and so on, is kind of metadata over your data that was there in HDFS earlier. So that's called metastore. For this, Hive uses MySQL in our case. It can use any other database as well and store this metadata. Yes, Kar, you've got it right. So to I mean Hive, the first step in Hive is to look at a data through a table structure. It's like viewing the file in the table format. Okay, for that translation to happen, we need to define the table format, like what is the data type under hood, and what are our columns that we are trying to make out, and what is the name of the table, and so on. Okay, that's the metadata, and that metadata is stored in the MySQL. All right. All right. Before we jump into Hive, let's understand the limitations as well. Yes, Pig doesn't have metadata. So question from Sunny, it can only deal with structured and semi-structured data. That's correct, Sunny, because we need to convert some data into tabular format, right? And that translation is most painful. For that translation, generally, we use the inbuilt, out of the box files, okay, such as the input formats. Those are the ones that will convert any raw data into something structured or semi-structured. Okay, unstructured data would be difficult, but there are ways of handling unstructured data in SQL. Okay, in Hive. So Pig can handle in the same way as Hive. It can also handle unstructured data. Okay, all right. A question from Manu: when we create a table and import data, where are we storing in? We are storing in HDFS. So when we will talk about this, we will generally, while creating a table in Hive, we will hardly copy the data. We'll either move or just point the data using using Hive tables. Okay, so it's like if you guys are from database background, so data files are HDFS file and table information is metadata. Okay, and based on the two, it generally creates the MapReduce job and get it executed. So out of SQL, whatever SQL queries you write, it'll try to create the MapReduce under the hood for the given table and get the work done. Okay, a question from Narendra. We have only seen flat file being analyzed with MR and PIG. What if the data comes in directories like India, AP, and so on? So yes, very good question, Narendra. This is where partition tables of Hive are very useful. Okay, we will go through that quickly. In the process of analyzing unstructured data, we have converted unstructured data into structured. Is this the only way to perform analytics? So in one way or the another, we'll always pick up the unstructured data and translate that data into either structured, or right away, if we can come up with some analytics, we can do that. So the general way of performing analytics is take unstructured data, convert into meaningful, and then process it. But sometimes, let's say we want to retain the structured data somewhere, you can keep that in different formats, say RC file format, so that you don't have to keep on converting unstructured data every time. Okay? Did I answer your question, Narendra? All right, wonderful. So now coming back to Hive, there are limitations with Hive. Hive, in at least so far the stable versions that are being used in the industry, it does not provide record level modifications. You cannot say update this table, modify this table, insert a column, and that kind of those kind of things. Because Hive was primarily designed for viewing the data, processing the data, or analyzing the data. But recently, Hive has started giving the insert, delete, and update. Okay, Hive has started providing the modification of data as well. Okay, but it's not yet in. It has not yet been industry wide accepted. Now, it can it can comfortably generate tables. Also, Hive is not suitable for OLTP, online transaction processing. Okay, why it's not suitable for OLTP? Because every every SQL query that gets converted in Hive translate to MapReduce and then it gets executed. And this translation execution is time consuming. This translation and execution is time consuming, and therefore for online transaction processing, Hive is not a great idea because there is overhead of MapReduce jobs. It is great when there is a data set which is maintained and to be mined. All right. All right. The architecture of Hive is like this. So you have Hadoop under the hood, although it is a diagram of Hadoop 1.0, but Hive has not changed much. So you have Hadoop under the hood, and on top of it, we have Hive. This entire thing is Hive. So there is the heart of the Hive is driver, which takes a SQL, which takes a Hive QL and translate it into MapReduce and executes on Hadoop. In this process, this driver consults the meta store and then get it done. Now rest of these are the callers of Hive. Using these command line interface, Hive web interface, or thrift server. Using these, we can make call to the driver. What is thrift server? It's a service architecture way. Okay, it's the way we basically I mean, let's say you want to launch your own web service. Okay, you can use thrift server. Thrift server makes it possible to provide API in almost every language for your service. Okay, so you can use JDBC or ODBC because of thrift server and execute anything as Hive query and so on. Okay, so most important thing here is this. The other difference from first difference from pig was that it stores metadata, like which table you're creating will be available in another session as well. That is one difference. Second difference of Hive from pig is that pig is only a client, pig is only a command, pig is not a server. Here, Hive is also providing a server. It's called Hive Web Server. Okay, this server keeps running, and once you create a table, it will stay there in Hive. And therefore, if you want to present data in Microsoft SQL or Microsoft Excel or Tableau, you can present data from Hive. So you process the data, create your table in the best shape, and then you create your reports or the visualization either in Tableau or the Excel or any other way. So Hive is more useful and is used in industry. So you can use BIRT, BIRT, Business Intelligence and Reporting, to present data from Hive. So if you really want to process and analyze and display the humongous data, probably Hive combined with a visualization tool will be a great idea. All right. So Manu's question is, how can we access Metastore? Okay, let me answer it in two parts. One, you don't generally need to access Metastore. Why? Because you generally talk to Hive, and Hive internally calls Metastore. But if you're still curious about Metastore, you can go to MySQL. There will be a table, there will be a database called Hive, and inside that there'll be the table called tables. There will be a table named tables, under which you will see that there will be a record for your table. All right. So this is a common architecture, and the Hive can be used from Hue or any other web interface. Okay. So a quick way to get started is, let's just get started. Okay. Let's log into CloudX Lab. Okay. Let's log into CloudX Lab. Let's log into CloudX Lab. And here we have Hive. All right, are you able to see Hive in the browser? In the Hue, are you able to click on Query Editor and Hive? Everyone? Okay. So another answer to your question, Shahida, sorry, Manu, you can go to Metastore tables and there you can take a look at the Metastore. Okay. Other than the previous question. Okay. So there are two ways. One is using the Hive and other is here. Okay. Here also you can import the data. You can create table from a file or you can create new table manually. Okay. You can give a table name and then you can provide HDFS file. Okay. and then move. So that is one way to create a table. Or we could go here and create. First, let's create our own database. All right, create database 15 Jan. Okay, then I'm going to say use 15 Jan. Okay, so it's working. And then inside that, I'm going to create the table. Let's say this is a simple table I'm creating. Okay, so all I did was create database 15 Jan, right? This is what I did. You can also create your own database and then get started. All right. And then you can actually load data into any file using this kind of model. Okay. You could say load data in path this into your table. Okay. A easier way would be to first copy this file to your home directory and then copy it here. All right. So yes. So this is the way we can get started with it. We will cover more details on Hive in the next session. Till then, if you want, you can finish the big quiz. Okay. Select star from 15 Jan is not a correct syntax, but select star from X is. Okay. Select star from X is correct sentence. All right. You have to use like whatever database you use, you have to say that. All right. So these are the things I'm using. All right. So basically, Hive is another very useful tool which can convert most of your SQLs into the MapReduce under the hood. So eliminating the use case of coding for MapReduce. Okay, 90% of the work can be done using simple SQL, while there'll be only 10% of the use cases where you have to customize the input format and do something which is not generally possible using Hive, okay, using an SQL query. A question from Pradeep. We use Hue in all real-time project, or is there any other tool? We can use the console as well. From console, we can simply type. In real-time projects, we generally use console. Let me be very honest with you. Okay. So here I can just type Hive and it'll start Hive. But this is far more reliable because Hue is editor from Cloudera, not from Hortonworks. So the companies which are using Hortonworks platform, there may not be a Hue may not be available there. Okay. A question from Kar. Is there a tool that can look into HDFS? and provide a data model. So see, most of these tools, whether R or R is one such tool. R can read data from HDFS directly and can start providing you the insights. Okay. The only problem with the R is that it cannot do the computation on a large scale because it will be loading the data on your local machine, and therefore that could become the bottleneck. Question from Narendra: does insert or update run MR similar to pig? There is no insert or update in case of pig or hive. It does create SQL plan, so you can always take a look at explain. So you can always take a look at explain, and it will show you the plan. For that matter, pig also has a way of understanding the data set. Okay, similar to explain. Okay, so that's pretty much for today. We got started with Hive. We closed our MapReduce today, and we also went quickly via Pig. A question from Kerr. I have a log file and how do I convert it? So basically, we use the load command. Okay, so we define a table. Okay, like we are doing is we're copying this big.txt to big copy in my HDFS. Then I'm loading it, creating a table. Then I'm loading this big dash copy into my table. Okay. I copied it because I did not want to mingle with big.txt. So then I loaded this into the table, and then I started doing rest of the work. Okay. Kar, does that answer your question? All right. So we will go into more details on how to load and what are the data types in case of Hive in the next session. Sudhakar's question is, does the file format in line with the definition? Very good question, Sudhakar. Let me try to explain this. So here we did not define any data format. We just said that load this data into our table, right? Now, when by default, while we are creating table, we define that this is the delimiter in the underlying file. Okay, this is the record delimiter, and this is the inside record. This is the column delimiter. Like for CSV, the comma is the delimiter between fields, and two records in CSV are separated by new line. So we define while creating table that underlying data is formatted in this way. Okay, while creating table, we can add the syntax here saying our underlying data is formatted in this way. I'm going to just skip to well ahead. So here we are saying that we are creating a table and saying the data is stored as ORC file. Okay, similarly, here we are saying create this data, create this table, while our row format is delimited and our fields are separated by tab and stored as text file. So while creating a table, we tell that underlying data is formatted in this way. So while reading from the table, it will try to parse the data and fit into that model. If while running the query, it finds that the underlying data is not fitting into the delimiter what we had defined, it'll give an error or the wrong results. Okay. Kurt's question is, what will that insert affects the underlying file? In the new model, it does. Okay. In the new model, insert actually inserts the data. Otherwise, it generally gives an error. Okay. All right, so that was our quick, getting started with Hive. underlying file is changed manually, let's say. So every time you query, it'll get you the latest data. That means if you modify it manually, the newer records will be shown to the user, right? You can either load the data by using the load command, or you can simply move the data into the folder where Hive is created. Okay, Hive file, Hive's table has the data folder. You can directly modify the data there or copy the data there. Okay, so it'll have the effect. Good question, great question. So we will go into more details into Hive in the next session, and then we will also cover in the next session NoSQL. Afterwards, we will probably start with the Spark along with Flume Scoop. Okay, so the next sessions are okay. Yes, we will clear all the DML operations on Hive, okay, in the next session. So I'm basically Hive, the people at Hive team, they themselves are not clear about DML. Okay, so most likely next session we are going to get started with the next weekend. We're going to get started with Spark, and then probably in the next weekend we are going to go with Scale Up. Okay, all right. All right. So, all right. Thank you, Alvin. I look forward to see you. Okay. And stay connected. And if you have questions, feel free to drop an email at support@nobigdata. All right. Thank you, everyone. Have a great week ahead. Bye-bye. See you next week.